Hello and welcome to Math Matters. I'm Miss Granados and today we're going to talk about the mean as fair share. By the end of today's lesson, you should be able to describe the mean as fair share and determine the mean of a group of numbers representing data from a given context as a measure of center. You will need some paper, something to write with, and about 30 small objects. You can grab maybe square tiles if you have them. If not, some beans, toothpicks, pasta, really anything that you can count and move around. So go ahead and gather your materials and come right back. Take a look at this picture. Which card doesn't belong? Select one of the pictures and explain your reasoning of why it doesn't belong to someone near you, or write it down on your paper. Also, can you think of why another picture doesn't belong? Or can you think of why each of the cards doesn't belong? I'll give you some time to think about it. Here are some reasons that I came up with. The top right card doesn't belong because 10 is the only even number out of all four cards. It's also the only composite number. The 3 doesn't belong because it's the lowest value. All the other cards are greater than 3. The 7 doesn't belong because it's the only card that shows diamonds. And the 5 doesn't belong because it's the only card that is black, not red, and also it's the only card that's not part of a fact family. 3 plus 7 equals 10. Did you think of any other reasons why one card doesn't belong? Let's move on to our lesson. Mario is playing a card game with 3 of his friends, Deshawn, Michael, and Joel. To play the game, each player needs the same number of cards. Mario doesn't feel like counting, so he just grabs a bunch of cards and gives it to each of his friends. Each friend counts his cards, and this is how many they each have. Joel has 9 cards, Deshawn has 14 cards, Michael has 17 cards, and Mario has 12 cards. What should they do to make sure they each have the same amount? Well, one possible option is to shift some of the cards so that those who have more can give to those who have less. In order to show you what that might look like, let's represent this data on a bar graph. Here you can see that Joel has the least number of cards and Michael has the most number of cards. In order to make sure that everyone has a fair share of the cards, Michael should give some cards to Joel. Since he has 3 more than Deshawn, let's have Michael give 3 cards to Joel. So now we see that Joel has 12 cards because he started off with 9 cards and then Michael gave him 3 more. so 9 plus 3 equals 12. Joel and Mario now each have 12 cards. Michael has 14 cards now, which is the same as Deshawn. What do you think the boys should do now? I'm thinking that if Deshawn and Michael give one card each to the other two boys, they'll each have the same amount of cards. So let's try it. Deshawn can give Joel one card and Michael can give Mario one card. You can see in this graph that all the boys now have the same amount of cards. And we can say that each boy has a fair share or an equal share of the deck of cards. These are the original number of cards that each boy received. After they redistributed their cards to make equal groups, each boy ended up with 13 cards. We can call 13 the mean of this data. Let's look at another example. Let's say you want to buy 6 different toys, and your mom asks you, about how much does each toy cost? She doesn't want to know how much each toy actually cost, but she wants to know what the average price of the toys was. Here are the prices of the 6 toys. If we create a representation for the prices the way we created one for the number of cards in our last example, we could represent the dollar amounts with square tiles, like this. Go ahead and take the small items you collected and create 6 groups with these numbers in each group. What could we do to figure out the fair share or the mean of this data? I'll give you some time to think about that question and to set up your groups with your items. If you remember from the cards, we took some from where there was more and gave to where there was less. So in this case, we can see that one column has 9 squares. We could take a few of those and give them to the columns with only 3 squares. Then the columns would look like this. 4 of the columns would have 5 squares, another would have 6, and another column would have 4. I can see clearly what we need to do next to make all the columns have 5 squares. Do you? Yeah, we need to move 1 square from the column of 6 to the column of 4. Now each column has a fair share. We can answer your mom's question of about how much does each toy cost. The average cost of the 6 toys you want to buy is $5. Let's look at another scenario. Samantha gives a handful of candy to each of 3 friends, just like this picture. When she realizes they each received a different amount of candy, Samantha says she knows how to fix that. What do you think Samantha should do to make sure each friend gets the same amount of candy? Take your small items that you collected and recreate this scenario. Figure out a way for Samantha to make sure each friend gets an equal amount of candy. I'll leave this slide up and give you about 2 minutes to work on this. There are a couple ways I thought of to answer this question. The first way is to take from the friends who have more and give to the ones who have less. I counted how many candies each friend had and got 8, 4, and 9. So I decided to take 2 from the friend who had 9 and give them to the friend with 4. I also decided to take 1 from the friend who had 8 and give to the one who had 4. With those changes, I can see that each friend now has an equal amount of 7 candies, or a fair share of the candies. Another way we could have solved this is to collect all the candies back from the friends and divide that total by the number of friends. So we know how many candies each friend has. There's 8, 4, and 9. So we can add all the amounts and get the total number of 21 candies. Then we can use what we know about multiplication and division and figure out that 21 divided by 3 is the same as 7. So each friend should get 7 candies. 7 represents the mean or the average in this scenario because it's the amount that is shared equally among the friends. So let's review what we learned today. We can find the mean of data by taking from the greater values and redistributing them to those that have less value. We did this with the deck of cards, the toy prices, and the candy example. Another way we discussed only in the last candy example was to add all the values together and then divide by the number of shares. We will be exploring this more tomorrow. These were the learning targets for today's lesson. How do you feel about your ability to describe the mean as fair share? How do you feel about determining the mean of a group of numbers? Make sure you write down any questions you might have so that you can talk to your teacher about them. This week we will continue learning about finding the mean or average of data, so make sure to come back tomorrow. For Math Matters, I'm Ms. Granados. Have a mathematical day and keep on counting.